This is one of the most fundamental proofs, and therefore we're going to have to prove it without relying upon any other theorems that we've already worked with. So we're going to want to prove that the angle at C, where the tangent touches a radius, is equal to 90 degrees. It's perpendicular. What we're going to do is show by a method called contradiction that no other straight line could be perpendicular. So FC would have to be. The only thing this relies upon is accepting that there must be at least one perpendicular line that goes from the tangent to the centre of the circle, and I think we can accept that. So let's move the diagram out of the way a little bit, because this proof is a little bit wordy and you're going to have to follow it line by line. So first off, let's suppose that FC is not perpendicular to DE. Instead, let's pick another line, and we'll pick that one FG, and suppose that that is perpendicular to DE. Now, obviously from the drawing it isn't, but we're going to suppose it is, because it doesn't have to be that far away. We're just drawing it that far away to exaggerate the effect. So if FGC is a right angle, this means that FCG must be acute, because in a triangle, angles in a triangle add up to 180 degrees. If one of the angles is 90 degrees, then the other two angles must be acute. Also, put very simply, if FGC, so the angle at G, is 90 degrees, then the line FC, our radius, is the hypotenuse. And the hypotenuse is the longest side in a triangle. So if that's true, then FC must be longer than FG. Just take a while to make sure you see that if the angle at G is a right angle, then FC must be longer than FG. Okay, here comes the contradiction. We know, because it's a circle, that FC equals FB. So that would also mean that FB is bigger than FG. Now look at the diagram. That's not possible, is it? FB cannot be bigger than FG. So our original assumption that FG is perpendicular cannot be true. Because if it was true, FB, the radius, is longer than FG. We can go through and pick any other line that you like, and the same thing will occur. We will get that contradiction. So the only line that doesn't occur for is FC. So that means that FC must be the perpendicular line to DE. So the angle where a radius meets a tangent is perpendicular, i.e. is 90 degrees, which is what we wanted to prove in the first place. We've relied upon no other information about proofs or theorems other than our knowledge of a circle and the radiuses are the same length all the way around it. This is one of my favourite proofs because it doesn't rely upon knowing lots of proofs and theorems. It relies upon pure common sense and logic and looking at a diagram and knowing some very, very simple facts. There are many, many other proofs and theorems in mathematics that work in this way.